So now we can introduce variables inside, and the same idea, they need to be like radicals. So for the first one here, again, in order to simplify, we need to write them as mixed radicals, and then we need to combine like radicals. Okay? Also in this question it says, where is each one defined? So we have to remember you can't take the square root or any even root of a negative number. So here we've got square roots. So a can never be negative. So for its, where is it defined? A has to be bigger than or equal to 0. Only positive values work. Then as far as simplifying, they're already as mixed radicals. 6 root a's plus 5 root a's would be 11 root a's, minus another 11 root a's, and you get nothing. So that one simplified is 0. For b, where is it defined? Again, we're dealing with square roots. Can you see inside we have a squared? A squared is always positive, whether a is a positive number or a negative number. So that won't affect our square root, and a can be anything. B, however, could be a positive or a negative number, but if b is a negative number, since 50 is positive and a squared is positive, if b is negative, that's going to be bad, because that's going to make the inside of my square root negative. So my b values have to be greater than or equal to 0. So it's defined when a can be anything, but b has to be bigger than or equal to 0. Now simplifying, we simplify our square roots, our numbers, and we simplify our variables. Now for 50, I hope you can see that 50 is 25 times 2. We still have an a squared b in there. Minus, and 8 is 4 times 2, a squared and b. So square root of 25 is 5. And inside we're going to be left with a 2. Now when you go to your variables, a square root says anytime you have 2 variables, you could pull out 1. For a cube root, you would need 3 of those variables inside to pull out 1. If it was a 4th root, you need like a b to the 4 to pull out 1. So since I have an a squared, I could pull out 1. And I would still be left with the b inside. Same thing over here. The square root of 4 is 2. I have an a squared. That would come out in front. And I'd be left with a 2b. So we've written them as mixed radicals. Now if you want to be really technical, since a is any real number, that means that when I pull out this a here or here, it could be a positive or a negative number. But the rule that we learned, that the square root of a number is always positive, so in order to show that, we need to add absolute value bars around that a. So I have like radicals here because inside the radical is 2b and 2b. So I have 5 of these minus 2 of these. I'm going to be left with 3, absolute value of a, root 2b. Because remember when we did this in 2.1? The answer is 5. Square roots are always positive. Even though a square root cancels out with squares, you have to write positive 5. And that's what's happening here. If a was a negative 3, negative 3 squared would be positive 9. And a 3 would come out, not a negative 3. So we just show that by putting absolute value bars there. And part C, where is this defined? First of all, they're cube roots. So for cube roots, it doesn't matter if it's positive or negative. So P could be any number, and Q could be any number. Thinking of your perfect cubes, 27 is a perfect cube. The cube root of 27 is 3. And for variables, now to simplify a cube root, you'd need 3 of those. So you notice that we have a p cubed there? So we could bring out 1p in front. And what's left inside is still the 1q. The second one, you have an 8 in front, you have a p cubed, means 1p would come out in front. So that's writing it first as mixed radicals and simplified. Now, notice that they are like terms. 3p cube root of q plus 8p cube root of q is 11p cube root of q. No absolute value needed here because we're dealing with cube roots. Absolute value is only needed with even roots. Okay. 5 and 7. Again, I'll give you some time to try those.